the connection between the cosine integral functions of two different types. Yeah, I think you know about this. Yeah, the first ci function is basically defined as negative of the integral from x to infinity of cos t by t dt, and all the cosine integral function written as cin of x. This is defined as integral from 0 to x of 1 minus cos t by t dt. Yeah. Now we want to find connection between these two functions. For this, we'll basically start with sin function and try to get a ci function from there. Let's see how can we. Okay. So let's proceed. Integral from this is basically LHS is integral from 0 to x of 1 minus cos t by t dt. Is that? Yes. Now let's try to convert this to integral from 0 to infinity of 1 minus cos t by t dt minus integral from x to infinity of 1 minus cos t by t dt. Yeah. Now the reason I'm doing this is, in our previous video we just saw that this over here can be taken in terms of the Euler-Masson constant in the following way. Basically, if we have limit g tends to infinity of integral from 0 to g of 1 minus cos t by t dt, and then minus ln of g. If you have this thing, this is basically just Euler-Masson constant, and this we saw this in the previous video. Yeah. Now how? Please note that I've just subtracted ln of infinity over here, and that I cannot really do. Yeah, but the reason I'm able to do it is over here also we have minus of integral from x to infinity of 1 by t dt, and then plus integral from x to infinity of cos t by t dt. Yeah, and okay, so now because I have written a minus, okay, this thing, I'll also write a plus limit g tends to infinity of ln of g, though this doesn't really make sense because I'm just subtracting infinities. Yeah, this might not seem proper, but yeah, for the second understand you can do that. Now we see that here it's just minus ln of infinity plus ln of x. Yeah, so that's why now these two will cancel each other out. So effectively now this will give us over here, this is Euler-Masson constant. Now over here we have minus ln of infinity plus ln of x. Infinity, ln of infinity, ln of infinity cancel out, so we just have plus ln of x, and then plus, now this is just minus of cix function. Yes, and yeah, that is the required result. Euler-Masson constant plus ln of x minus ci of x, and this is what we begin with, that is cin function, and that proves it. Talk about the flow, we just began with the cin function and made some integral changes using the properties of integrals, and then added and subtracted ln of g where g goes to infinity, and yeah, that's all the entire problem. So that was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.